Now let's talk about the third property of whole numbers. Third property is associativity. Now let's add three whole numbers. Let's say 2 plus 3 plus 4. Okay. Now what we do is we associate the first two. Okay. Now first add these two numbers. 2 plus 3, 5, right? Then what we are remaining with plus 4. Okay. Now 5 plus 4 is 9, right? So 9 is our answer. Now take this thing again. 2 plus 3 plus 4. Now instead of associating 2 and 3, let's associate 3 and 4 this time. Okay. And add these first. 3 plus 4 is 7, right? What we are left with? 2 plus 3 plus 4, 7, right? And now 2 plus 7 is 9, right? So in both the cases, our answer is same, right? So this is called the associative property. Okay. Similarly, let's do the same for multiplication. 2 into 3 into 4. Let's multiply the first two. 2 into 3, 6, multiplied by 4. Now 6 into 4, 24, right? Now again 2 into 3 into 4, but this time associating 3 and 4. Solving it, 2 into 3 into 4, 12, right? Now what we are left with? 2 into 12. 2 into 12 is 24. In the case of multiplication also, our answers are the same. This is called the associative property of whole numbers, right? Now let's try to understand how the associativity helps us. Okay, let me first erase this and let's take another example. Let's multiply. Let's do 9 into 4 into 25. 9 into 4 into 25. Okay. Let's first associate the first two. Right? 9 into 4, 36. And now what we are left with? 36 into 25. Now what you will do is, you will do like this, right? To come to our answer, right? And then the answer will be here, right? But let's talk the other way. Let's associate the second and third number. 9 into, we know 4 into 25 is 100. Now we are left with 9 into 100. 9 into 100 is 900, right? So this way associativity makes our calculation easy, right? So this way we easily calculated the value, but here it was time consuming. So this is how associativity helps us. Now let's talk about another property of whole numbers. Now let's take a graph paper of size 6 by 8 centimeters, right? In which each square is of size 1 centimeter, right? So what will be the total number of squares in this graph paper? It will be 6 into 8, right? 6 into 8, right? Now let's do one thing. Let's cut this graph paper from here, which means 5 columns different and 3 separate, right? Let's draw it. Now when we cut this graph paper from here, we get two graph papers, right? One will be having number of squares for the first graph is 6, into 5, right? And for this graph, the second part, what will be the number of squares in it? The number of rows is 6 and the number of columns we have 3, right? So when we cut this graph paper, the total number of squares will remain the same, right? The total number of squares are not going to decrease or increase, right? So can we say that this 6 into 8, this graph paper is equal to this plus this, which means 6 into 5 plus 6 into 3, right? We can say this thing. Now let me erase this. From the graph papers, we saw that 6 into 8 is equal to 6 into 5 plus 6 into 3, right? Okay, let it be the equation number 1, right? Also, we also know that 6 plus 8 can also be written as 6 into 5 plus 3, right? 6 into 8. We split 8 into 5 plus 3. 5 plus 3 is 8. Now this and this is same, right? Let it be equation number 2. Now what we observe from these two equations? 6 into 8 is equal to this. 6 into 8 is equal to this, right? Which means this part and this part, they both are same because they both represent 6 into 8. This also represents 6 into 8, right? So from 1 and from equation number 1 and 2, we can say this thing 6 into 5 plus 6 into 3 is equal to 6 into 5 plus 3, right? So this is what is the distributive property of whole numbers. Okay, so in general, if I want to write what is distributive property, it can be written as if A, let it be A, B and let it be C, right? A equal to 6, B equal to 5 and C equal to 3. So what it will be? A into B plus A into C is equal to A into B plus C. B is 5 and C is 3. B plus C. This is what is the distributive property of whole numbers. Let's try to understand this distributivity in another way. Let's take this portion. A into B plus A into C, right? Simply, in order to come to this thing, what we can say, simply we can say from this and this, A is common in both the brackets, right? Let's take A outside, right? What we are, if we have taken one outside, then what we are left with? B. We take A into and B into, right? This thing is common and after taking this part and this part common, what we are left with is b from here, and then the plus sign, and then c. This is how we can easily learn how to calculate the distributivity. Now let's talk about the last property of whole numbers, which is a property of identity. The property of identity is of two types, additive identity and multiplicative identity. Now let's talk about these. Additive identity is what? Let's tell me one number which we when add to any whole number gives us the same whole number. For example, let we take the whole number 8. Now we have to add another whole number, by adding which we get the same number. Which, if we add 0 to 8, what will be the answer? 8. We took this number, added 0 to 8, and we got the same number. Similarly, we can talk about any whole number. Let's say we take 10 and add 0 to 8. What will be the answer? 10, right? So whenever we add 0 to any number, we get the same number, right? So 0 is the additive identity, right? Similarly, multiplicative identity. Here we have to find such number which when multiplied by a certain number giving us the same number. Let's take 8. Multiply it by 1. What we get? 8, right? We got the same number. Similarly, on multiplying by 10 with 1, we got 10, which is again the same. So 1 is a multiplicative identity.